This is the first of a series of videos in which we're going to be looking at section 1.4. This is part 2. We already did factorials, but now we're going to be finishing up the section and looking at permutations and combinations. So we're going to start with a couple of explorations, exploration 1 and exploration 2, and I would even invite you to turn your video off for right now for just a moment. Try the two problems on your own and then turn your video back on again, and I'll walk you through them. All right, so if you're ready to go through these two explorations, you've tried them. Let's go through them together. So the first problem says, suppose that Allie, Bailey, Caleb, and Daniel are 4 members of the tennis team. We're going to choose 2 of them to compete in the doubles competition. And we want to make a list of all the possible ways that this can be done. And we want to make the list in kind of an organized way. So we might start out and say, well, we could put Allie with Bailey. So let's do A and B. And we wouldn't want to list B and then A as a separate choice because Bailey and Allie together would be the same team as Allie and Bailey together. So we just need one of them. We don't need both of them. And then we might say, well, we can put Allie with Caleb. So we could do Allie, Caleb, and then we could do Allie, Daniel. All right, so now we've really paired Allie with everybody that she can be paired up with. And so now we'll move on to Bailey. And we'll say, who else can Bailey be with? Well, Bailey's already been paired with Allie, so we're not going to go backwards, but we could do Bailey and Caleb, and we could do Bailey and Daniel. And that kind of takes care of Bailey. Bailey's been paired up with everyone. And then finally, we can say, all right, let's move on down to Caleb. Caleb's already been paired with Allie and Bailey, so we don't want to go that way, but Caleb could be paired with Daniel. Then when we get to Daniel, we can see that Daniel has already been paired with everybody. Daniel's been paired already with Allie and with Bailey and with Caleb. So it looks like we have 6 different ways that we can make the teams. All right, then when we look at exploration 2, this time it says that Allie, Bailey, Caleb, and Daniel are going to hold a singles competition between themselves, the 4 of them, and they're going to award medals to the first and the second place winners. It says make a list of all the possible ways that this could happen. Well, this time, if we have Allie and then Bailey, or Bailey and then Allie, those are different, aren't they? Because in this case, Allie got the first place and Bailey got second. But in this one, Bailey got first and Allie got second. All right, and I would think that they would say that those are different. And so if we're going to come up with this one, a convenient way to organize this information is with a tree diagram. So we could have one column that says, here's the first place winner. And then we'll have another column that is the second place winner. All right, so this time, the first place winner could be Allie, could be Bailey, could be Caleb, could be Daniel. All right, and then if Allie wins, then it is possible that there are 3 different people that we could have for second place. So it could be Bailey, Caleb, or Daniel. If Bailey wins first place, then the second place could be Allie, Caleb, or Daniel. If Caleb wins, it could be Allie, Bailey, or Daniel. And if Daniel wins, I'm kind of running out of space here. Again, there could be 3 choices. It could be Allie, Bailey, or Caleb. So if we wanted to make a list of those, we could say, well, we have Allie, Bailey, Allie, Caleb, Allie, Daniel coming out of this. And then we would have BA, BC, and BD coming out of this one. And then we would have CA, CB, CD coming from here. And then we would have DA, DB, and DC coming from here. Another way you can think about it is every time we had a pairing up here, AB, excuse me, both AB and BA had to go in here. When we had AC, both AC and CA had to appear. AD, we had AD and DA that appeared. BC, we had BC and also CB had to be on our list. For BD, we had BD and then DB. And then for CD, we had CD and DC. So you can see in this one that for every entry that we had over here, we actually ended up with 2 times that over here. So we had 12 of them altogether. So this is an illustration of two related math topics, permutations and combinations. So permutations is simply any arrangement. A permutation of a group of symbols is any arrangement of those symbols in a definite order. So it asks, which example illustrates a permutation? Well, the one that illustrates the permutation is number 2, all right? Because those are in a definite order. The order matters in that case. A combination is a selection of objects without regard to order. So in other words, we select the objects, but we don't care what order they're in. And so it says, which example illustrates a combination? That would be number 1. And so, as it says here, if you're given a set of objects, are there more permutations or more combinations? Hopefully you already have a sense in looking at this one example that there are more permutations. And the permutations will kind of come from taking a particular combination and then arranging them in different orders. So taking the AB and arranging it into AB and then the BC. So more permutations than there are combinations.